So dear Ontochain colleagues, here is a video demo just showing how we implemented all the progress here in our platform. Okay, you will see the current status of everything. So first of all, here in the main side, I am accessing to the platform, all right? And the very first thing we can see here is a dashboard just showing the transaction history that represents the total number of transactions committed, okay? Now, the thing is that this is still in a temporal way. So what we are doing next is just to show how we introduce the different sensors in the given platform. So here you can see several platforms, and here in this particular part, you can see here how you can introduce the different ontologies, in particular in the platform for the sensor list. This particular sensor can accept several specifications, and as you can see here, for the moment we don't need more specifications, but here it is possible to include different ontologies representing the specific sensor, right? It is possible to generate a new one like this one here, and it will be also showed here underneath. Now we're going to show a general project. We're going to test Ontochain, this one that has been already done for us previously, showing a sector where we need to deploy 27 water quality sensors like the ones that you can actually see here. Okay, we have here in the map 27 sensors, and each one is going to be represented here. Okay, as you can see, we have selected among the database for each particular spot. We have the unique ID that represents that specific device, and it's going to go to the blockchain along with the other information. And then we have everything for the different spots and sensors located here. Okay, actually this has the very same identifications than those that are actually given in the particular data set that we trained with ADOS. Okay, so we have all this here, okay, until the last one. And once we have everything selected, then the next step is just to generate the infrastructure, which is right here. We have, first of all, our infrastructure logging endpoint, where we can get our bearer token that we will use in order to connect to the other endpoints. Okay, so for example, we have two types, infrastructure and ADOS. All right, and here we have the specific information that will be used in order to identify everything. Now, these endpoints are all submitted to we will see next the infrastructure, because we will need to understand how everything is working. Okay, so here this is the first part, but whenever there is an endpoint receiving data from the outside, then what we do is just to accumulate these in several queues depending on the specific commit period. So whenever a sensor is submitting information, for example this one, to this specific endpoint, then all of them, when they belong to the same project, they are stored actually in the very same instance. Okay, so once the commit interval expires, then the specific setup of transactions is either submitted raw to the blockchain or it goes through ADOS. So what we give our clients is the chance to have different commit time intervals. So it is on their own criteria how they decide to certificate or to hash the information. Okay, the shorter the time span, then normally the more expensive it is going to be. Okay, so again, this is an infrastructure we are adopting right now because we're changing everything to make everything much more scalable. Additionally, we're including, well, MQTT protocol is also considered here, and the thing is, I'm going to show next how this works. Okay, how the MQTT protocol actually works. So here we have the MQTT protocol. We can see here all the two brokers for credential and data, and then the different options, including subscription, publication, and publication. The first two ones are basically used for having the password to connect and submit data to the particular topic shown here. We have there in this particular MQTT all the possible topics and channels that can be used to connect all this information, just as you can see here. Okay, and again, the specific setup of queues is going to determine how data is stacked on top of each other, okay, before sending it to ADOS in batch or sending it also in batch to the blockchain directly. Remember that the ADOS batch will also have the particular readings along with the data quality factors. Okay, and we generate the specific evidence that is stored in MySQL along with the data that can be used later in order to retrieve where, well, the particular evidence that is going to be useful for us to audit the transactions here, okay? So this is it. Now we are going to open Postman to see how this particular operation here takes place, because again, what we see here in the specific database, or better said, in the API dynamically generated, is only for sending data in a granular fashion, okay? Because data is accumulated here until it is transacted via ADOS, all right? So now what we do is just to go to Postman and check what happens, because we already have a batch accumulated when we do this specific call. So we open Postman here, we have our URL, as you can see here, and then what we do is just to submit the call here, okay? That includes the different batch. It is now being processed, all right? And this is what we retrieve from the ADOS transaction. We made it faster so that you can see it here in short, okay? And then as you can see, we have the specific device ID and all the timestamps that were actually incorporated in the CSV file that was submitted. And you will see here some specific moments when there is an attack or there is an anomaly. And we have this here for all the specific devices, as you can actually check here. So later, what a specific client can do is just to retrieve all this data dynamically and check it against the blockchain and verify that everything was actually good. That's it. So additionally, before ending, well, just say that we are increasing the team. There are 2 new developers here, and our plan is just to have everything up and running in short. Thank you very much.